Now, till now, we had uh, learn about how the work energy theorem etc. is applied. Now, okay, so we should further look into the matter and see how the things are related with each other. Okay, so energy will conserve. Energy will conserve. Okay, potential energy. Let me write down potential energy plus kinetic energy plus kinetic energy. This should be constant. Okay, constant when all when work done by work done by external force external force work done by external force is zero first thing, and second is work done by all work done by all non-conservative non-conservative conservative internal force. Okay, non-conservative internal force work done by all non-conservative internal force internal. Okay, check the spelling. Internal force when work done by all non-conservative internal force will be zero. Okay, will be zero. So okay, potential energy plus kinetic energy is equal to constant, and work done by all external forces is zero, and work done by all non-conservative internal forces will be zero. Okay, so in this manner, okay, work done by all non-conservative internal forces will be zero, work done by all external forces will be zero. So in this case, um, potential kinetic energy plus potential energy, this means this energy called mechanical energy. Some of the kinetic energy plus potential energy called mechanical energy. So in this case, mechanical energy is conserved. Okay, is conserved. Okay, guys, and sometime in most of the situation, most of the question, most of the cases, people ask question based on this concept. Okay, but sometime uh, an external forces is present, so in that case we will just do simple, um, we just use simple, uh, okay, work energy relationship, just like that. Net work done is equal to change in kinetic energy. So you know k2 minus k1, this should be equal to work done by external force, work done by external force, okay, plus work done by non conservative internal force. Okay, non conservative internal force. Okay, and plus work done by conservative internal force, conservative, this will become, so it will become minus p2. Okay, minus p1, work done by conservative internal force is equal to minus change in potential energy, so minus change in potential energy. Okay, so what can I write? K2 plus P2, K2 plus P2, this should be equal to K1 plus P1 plus these things. Okay, work done by external force, work done by external force plus force plus work done, okay, by non-conservative internal force, work done by non-conservative internal force, okay, plus work done by non-conservative internal force, non-conservative internal force. Non-conservative internal force. So okay, this should happen. If this quantity is 0 and this quantity is 0, then energy will going to conserve it. This is not 0, then it will take relation like this. Okay, so you should not just memorize these things. Okay, you should not memorize this relationship. Just simple, you should know about what is this relationship, very important. Okay, this relation, change in kinetic energy, this equal to work done by external force plus work done by non-conservative internal force plus work done by conservative internal force. Okay, so this relationship is very important and you should know this. Okay, now we are going to discuss about potential energy again, potential energy of spring. Okay, potential energy of spring. Now we are going to discuss about potential energy of spring. Okay, so it is very simple to establish potential energy of spring. Okay, I say that spring has potential energy. It means that spring force is conservative. It means that spring force is conservative. It also means that work done in a closed loop. Work done in a closed loop. Uh, Work done in a closed loop should be 0. Work done in a closed loop should be 0. So let's check. Work done in a closed loop should be 0. Okay. Work done in closed loop. Closed loop by spring must be 0. So let's check. Okay, this is the one end of a string is tied, has been tied. Okay, this end is fixed and this is attached. Okay, now let's suppose I move the spring, the block in this direction. Okay, so what is the force? If draw the free body diagram, if I draw the free body diagram, so this will be the force by spring. Okay, this is the force. Okay, so let's suppose I take it from here and displace it to this length. Okay, and then come here, so this become a closed loop. So try to find out what is the work done when it goes from here to here. Okay. Okay, so what is the force? Force is equal to kx. Okay, so what is the work done? W is equal to kx dot dr. Okay, so what is the what is the displacement? Displacement is in taking place this direction. So what is the angle? 180. So this will be minus. Okay, so should I write minus k x dx? Okay, so differentiation this will become minus k x square by 2. Okay, and if you look at this, from x is equal to 0 to x is equal to L, from 0 to okay, let me call it x, from 0 to x. So what I get, minus k x square by 2. Okay, Now, now, and again, now it's moving in this direction. It's moving in this direction. Okay, so again, for direction of force is this, and what is the displacement? Displacement is also taking place in this direction. Okay, so plus, so same thing happen, and here sign become plus. Okay, kx square by 2. So what is the work done? Work done is equal to 0 in closed loop. Okay, so spring force is conservative force. Okay, spring force is conservative force. Conservative force. Conservative force. If spring is conservative force, so what is the potential energy? Potential energy due to spring is half minus of work done by spring minus of work done by spring. So what is the work done by spring? If you look at this work done by spring, this is the change in potential energy. Okay, this is potential energy. So minus of work done by spring is equal to, okay, initial, let's suppose initial here at this point potential energy of spring is P1. Okay, and at point position X this potential energy is P2. So what is the change in potential energy? P2 minus P1. This should be equal to, this should be equal to uh, this should be equal to uh, minus of, what is the work done from this, minus half kx square. Okay, so this become equal to 1 by 2 kx square. Okay guys, so P2 minus P1, this should be equal to this. Okay, you know, so you're changing the potential it is. Now guys, one thing is important is that, you could choose, you could choose any of P1 and P2 as 0. Okay, so I will discuss about these things in later stage of, okay, the lecture. Now, so this is the how potential energy relationship stabilized for spring. Now now we are going to discuss about uh, gravitational potential. Now we are going to discuss about gravitational potential energy. Okay, okay, gravitational potential energy. So first we have to check that is gravitation is conservative force or not. Okay, force due to gravitation is conservative or not. We have to discuss it first. Okay, we have to discuss it first. After that we will uh, try to find out the relationship potential energy due to gravity. Okay, due to gravitational force. Okay, so uh, here let's suppose, okay, first check. I throw a ball. I throw a ball from the ground. I had thrown a ball. Okay, ball reached at this point. Ball reached at this point, and then it come back. Then it come back. Okay, then it come back. Okay, so what is the work? Okay, so this height is h. Let's suppose. Okay, so in first, from this position, let's suppose this position is 1, this is 2. From 1 to 2, from 1 to 2, what is the work done? If you look at this carefully, if I draw the figure diagram of this, there is the force mg. Okay, and here, what is this angle? This angle is 180. Okay, so work done will be, f dot d f dot d, this will be minus. Okay, so from here, so dw is equal to minus f sorry, did f dot dr. So this will be, if I integrate this, so w will be f is mg, and dot dr dot product will be, okay, mg dr, and what is the angle between cos 180, this will be minus 1. Okay, cos 180, that will be minus 1. So this will be minus mg, and dr, this is the from 0 to h, so this will be h minus mgh. Okay, so what is the work done? Work done by gravity will be minus mgh. Okay, now from 1 to 2, 2 to 1, sorry, 2 to 1 again here, this is mg, and displacement is taking place in this direction. So what is the work done? Work done will be, okay, look at this here, work done will be, work done will be mgh. Okay, mgh, because angle between them is 0, so work done become mgh. Okay, so now what is the net work done from this is the work done from 2 to 1. So what is the net work done? Net work done will be minus mgh plus mgh. Okay, you should do it by yourself. So this is conservative force. Again, gravitational force is conservative. Gravitational force is conservative. Okay, gravitational force is conservative. Now, gravitational force is conservative, then potential energy will be associated with this force. Okay, gravitational, so potential energy will be associated with gravitational force. Okay, potential energy associate with conservative. Potential energy will associate with the gravitational force. Okay, gravitational force. Okay, guys. So okay, so so what is the potential? What? Okay, okay. So gravitational force. Okay, so now we are going to find out what is the potential energy. What is the potential energy? So let's change the page. Okay, what is the potential energy? uh, Gravitational potential energy. Okay, so change in potential energy p2. Okay, let's see a situation. From here I had throw a ball which reach to height h. So what is the change in potential energy? Change in potential energy this is equal to minus of work done by internal forces minus of work done by internal forces. Okay, internal internal conservative forces. Conservative force. Okay, so okay, change in potential energy is equal to minus of work done by internal conservative force. Okay, this is the height h. So what it become? So okay, what is the work done? If you look at this carefully here, if I draw the figure diagram, this is the mg, and this is the direction in which displacement taking place. So what is the angle between this? Angle is 180. Okay, so cos 180 minus 1. So my minus mg, this will be dh from h0 to h. Okay, so let's suppose here potential energy is p1. Okay, so p2 minus p1 is equal to, okay, this, and here the sign will be minus. Okay, which this is the work done minus mg dh. This is the work done. So I get mg mgh, and this will be 0 to h. So work done is equal to change in potential energy is equal to mgh. So P2 minus P1. Okay guys, so here we had established what should be the change in potential energy from P2 to P1 is equal to mgh. Okay. Okay, you know guys, to make the to make the analysis simple, to make the analysis simple, people take P1 P1 in any case. Either you are solving for spring, or either whether you are solving for question of related to gravitational potential energy, most of the time people choose any of this, any of P1 or P2 as 0, whatever they want, and then they try to solve the question. So due to it, one expression has vanished. Okay, and due to it, the writing the equation becomes simple and the calculation becomes simple. Okay, so people choose any potential, like most of the time 0, because multiplication with 0 and addition with everything will become 0. We have to not bother about anything, because 0 will make everything 0. Okay, its addition will not affect it, subtraction will not affect it. So 0 is the good guy to keep the value in such cases. Okay, so in this manner we had seen that how potential energy and conservative, non-conservative, these things are related to each other. Now, if you want to see what is the power of this statement, then you have to solve the questions. Okay, now it's time to solve the question. And we will solve so many questions, okay, on conservation of energy. Okay, so we'll do it in next class. Okay, thank you.